Welcome to Bot Thoughts by AmtocSoft. I am Alex. In January, I shipped a code review agent. It extracted structured findings from an LLM response, file path, line number, severity, description, and filed them as tickets. It worked in testing. In production, it broke within 4 hours. The model returned a finding with lines set to the string around 42 instead of an integer. Pydantic threw a validation error. The batch failed silently. The agent kept appearing to run, but it had stopped producing output. Nobody noticed for 3 days. When I went to debug it, I assumed the issue was the prompt. I spent 2 hours writing increasingly elaborate instructions about always returning valid integers. That did not fix it. What fixed it was removing the problem from the model's decision space entirely. That is what today's episode is about. Let's start with the failure mode almost everyone hits first, the prompt-only approach. The tutorial pattern goes something like this. You write a system prompt that says, respond only with valid JSON, or always return a JSON object matching this schema. And it works in your tests because your tests use clean, simple inputs that produce clean, simple outputs. Production is different. In production, you get 5 categories of schema-invalid responses, and they all look reasonable to the model that produced them. First, prefix text. The model outputs something like, here is the JSON you requested, and then starts the object. That prefix text breaks any JSON parser. Second, trailing commas. JavaScript-style trailing commas after the last field, valid in JavaScript, invalid in JSON. Models see enough JavaScript in training that this is a common pattern. Third, null versus empty array. A schema that expects an empty list gets null instead. The model's prior is that null and empty list mean the same thing. They do not mean the same thing to a type validator. Fourth, inline comments. The model includes a note like this field will be empty until phase 2 in the JSON body using JavaScript comment syntax. Also invalid JSON. Fifth, markdown code fences. The output is wrapped in triple backtick JSON, which is the correct format for a markdown document, but not for a raw API response your code is trying to parse. None of these are hallucinations in the traditional sense. They are statistically plausible continuations of the prompt given the model's training distribution. You cannot prompt your way out of this. Adding more instructions just shifts where the failure probability sits. You are playing whack-a-mole with a probability distribution. So what is constraint generation, and why does it actually solve the problem? To understand it, you need to understand how token sampling works at the model level. When an LLM generates text, it does not produce one word at a time. It produces one token at a time, and a token is typically 2 to 4 characters. At each step, the model computes a probability distribution over its entire vocabulary, often 50,000 or more tokens, and samples one token from that distribution. Constraint generation inserts a step between the probability computation and the sampling. It takes the full probability distribution and multiplies it by a mask, a vector that is 1 for every token that is valid at this position in the output and 0 for every token that is not valid. Then it samples from the masked distribution. The mask is computed by a finite state machine. The FSM tracks exactly where you are in the output grammar, in our case, a JSON schema, given every token that has been produced so far. If you are at a position where the schema requires an integer, the valid token mask allows digits and minus signs and nothing else. The string around, or the string null, or a markdown backtick, none of those tokens are in the valid set. The model cannot produce them even if their raw probability is high. There are 2 important properties of this approach. First, the FSM is compiled once per schema and cached. It does not rerun for every token. The per-token mask lookup is a fast set operation, typically under 5 milliseconds of overhead per full generation. Second, the output is still probabilistic. The model still samples from a distribution. The content of your string fields, the ordering of optional fields, the specific enum value chosen, all of that is still model-driven. What constraint generation gives you is a guarantee about shape and type. Every possible output the model could produce is schema valid before it ever gets sampled. That is not a retry strategy. It is a structural guarantee. Now let's talk about how to use this in practice, starting with the Anthropic API. Anthropic's constrained generation interface is tool use. When you define a tool with an input schema and set tool choice to any, you are telling the model, your response must be a tool call matching one of these schemas. The token-level FSM is applied automatically. You do not need to install anything extra. Here is what the call looks like for the code review agent from the cold open. You define an extract findings tool with a schema. Each finding has a file, a line as an integer, a severity as an enum with 4 values, info, warning, error, critical, and a description as a string. You set tool choice to the type any object, which means the model must invoke at least one tool and it may invoke multiple. When the response comes back, you access block.input on each content block. That is already a Python dictionary matching your schema. You do not call JSON.loads. You do not run it through Pydantic. You do not have a try except block around a validation step. The shape guarantee is applied at the token level before the response is even transmitted to your client. The silent failure from the cold open cannot happen. The token around is not in the valid token set when the schema position requires an integer literal. The model simply cannot generate it. One additional option worth knowing. If you need exactly one tool call per request, you can set tool choice to the type tool with a specific name. That constrains the model to invoke that exact tool once. Useful for extraction tasks where multiple invocations would be nonsensical. Here is the subtle sign that you are solving the right problem now. The validation error handling code disappears from your code base. You no longer need a retry loop for parse failures. You no longer need a Pydantic validator wrapping the model output. When you find yourself deleting that code, it is a signal that the constraint has moved to the right layer. What if you are running local models? If your stack includes Llama, Mistral, 5.4, or any other self-hosted model, the Anthropic tool use interface is not available. But the FSM-based guarantee is through the Outlines library. Outlines is an open-source library that adds constraint generation to the Hugging Face Transformers stack. The API is deliberately minimal. You load your model as normal. You call outlines.generate.json with 2 arguments, the model and a Pydantic class. That compiles the FSM for your schema. Then you call the return generator with your prompt, and you get back a typed Pydantic instance. Not a string, not a dictionary, a Pydantic instance. No parsing step at all. The compile step runs once per schema and is cached. If you are serving many requests with the same schema, you compile once at startup and reuse. Outline's own benchmarks show throughput within 2% of unconstrained generation for schemas up to 20 fields. The overhead is in the mask computation at each token step, and for realistic schemas, that overhead is small. The same structural guarantee applies. If your schema says a field is an integer, the FSM will not allow the model to produce anything but an integer at that position. The guarantee is identical to what you get with Anthropic's tool use. The implementation is different. Outlines hooks into the logits processor at the token sampling layer, but the property is the same. If you are building a system that needs to run across both cloud and local models, the pattern is consistent enough that you can write the same downstream code. Schema-valid output, no parsing step, type guarantees. The tool use wrapper on one side and the outlines wrapper on the other are both doing the same work at different layers of the stack. Constraint generation does not solve everything. There are 3 failure modes that survive, and you need to plan for all 3. The first is semantic invalidity. Constraint generation is a guarantee about shape, not meaning. If your schema has a severity enum with 4 values, info, warning, error, critical, the model will always output one of those 4 values. It will never output a string that is not in the enum. But it can output info when the finding should clearly be critical. The shape is valid. The meaning is wrong. Your eval layer, your human review process, your downstream quality checks, those are still necessary. Constraint generation does not replace them. The second failure mode is truncation. If the model hits your max tokens limit in the middle of producing a JSON object, the output will be structurally incomplete. The FSM does not know about token limits. It just knows what tokens are valid given what has been produced so far. If you cut the generation off mid-object, you get an incomplete object. The fix is to set max tokens to your estimated output size times 1.5 and never leave it unbounded. For structured extraction, your output size is predictable from your schema. Calculate it once and set an explicit limit. The third failure mode is schema and prompt mismatch. If your schema requires fields that your prompt never set up context for, a field called affected component when your prompt only describes a line of code, the model will still produce a value for that field. It will just produce a low-confidence guess. Constrained generation enforces the schema. It does not ensure the prompt prepared the model to populate the schema meaningfully. That alignment is your responsibility to maintain, as both the prompt and the schema evolve. Let me close with the production pattern that came out of 6 weeks and 22,000 calls with this approach. 5 practices made the difference. First, tool use with tool choice any on every structured extraction call. No exceptions for simple schemas. The overhead is trivial and the guarantee is total. Second, strict types and enums for all categorical fields. If a field can only be one of 4 values, model it as an enum. Do not use a string field and then validate downstream. Move the constraint to the generation layer. Third, add max length to string fields. JSON schema supports max length on strings. Use it. This prevents the model from producing a 2-paragraph explanation in a field that should be a 1-line description. Fourth, bound max tokens explicitly. Calculate your expected output size for the schema, multiply by 1.5, and set that as the hard limit. Never leave it at the API default for a structured extraction call. Fifth, structured escalation when the tool call count is 0. Sometimes the model does not invoke a tool at all, even with tool choice any. This usually means the input did not contain anything matching the extraction target. Handle this as a distinct case in your application logic, not as an error. The result after 6 weeks: 0 schema validation failures across 22,000 calls. The bugs that remained were semantic. The model categorized something as info when it should have been a warning, or generated a vague description for an ambiguous finding. Those are the interesting bugs. They tell you about the limits of the model's understanding, not about the limits of your plumbing. That is the shift constrained generation enables. Your debugging time moves from JSON parse errors and retry loop tuning to actually evaluating output quality. That is where the interesting work is. Full code at github.com/amtocbotdroid/amtocbotexamples/structured outputs. Blog 268 has the written version with the full schema walkthrough. Long-form video V040 covers the same ground visually, and shorts S160 and S161 have the highlights. Subscribe to Bot Thoughts for the next one. I am Alex, and I will see you next